Okay, so if we sketch this region, this is going to be a vertical line, and it's solid because it's equal to. Just looks like this. So again, we're looking at a vertical line because it's x equals. So I'm going to make it dotted because it's actually, I guess, less than. We'll shade in just a second. So y is less than or equal to 3. That's a horizontal line. Solid. So I need to shade below because that's less than. So below the horizontal line, that's less than, which means to the left, or smaller than the vertical line at 4, so all of this area would be shaded. So this one, certainly could draw it. I'm just going to kind of figure it out algebraically. So the distance AB, using the distance formula, would be, so that's 10 minus 5 squared plus negative 4 minus 8, which is, let's see, that'll be square root of 5 squared, which is 25, plus negative 12 squared, which is 144. So that's, sorry, equal to the square root of, I guess, 169, which is 13. So the first distance we have there, AB, is 13. BC. X1 minus X2, 1 minus 10, 20 squared. And BC, so be negative 3 minus negative 4, which is negative 3 plus 4. So that'd be negative 9 squared, which is 81, plus 1 squared, which is 1, so square root of 82. Might be able to be simplified. AC. It's going to be, let's see, 1 minus 5 squared plus negative 3 minus negative 8, which is negative 3 plus 8, which is square root of 16, plus 5 squared is 25, which is 41, square root of 41. So using the reverse, the a squared, the converse, I guess, plus b squared equals c squared. Let's try to prove this is right triangles. So this would be square root of 41 squared plus square root of 82 squared equals square root of, I'm just going to leave it as, it would be easier. I'll just write 169 squared. If you want to write it 13, that'd be fine too. So this would be 41 plus 82 is 169. So I think I discovered an error here. Looking back at this, it didn't work out, and it says show, which makes me think, yeah, this is going to work out. And so I think I just made a mistake here. So it should have been negative 4 minus negative 8, which would be plus 8 here, which means this is 4 squared, which means this is 16, which means this is 41, square root of 41. So now I have, this is 41 here, square root of 41 squared. So this is 41 plus 41 equals, or now this is the longest side, right? So I would have to put that in there, square root of 82 squared, which is 82, by the way. And so that works. So I have proven that it works. Just made a little error in there. Again, because the way the question's phrased, show that the triangle is in fact a right triangle, makes you believe it is a right triangle. You just have to show it using the theorem. So I kind of figured out I had to make a mistake, just went back and looked at it and found the mistake. Make a table of values and sketch the equation, then find the x and y intercepts of the graph and test for symmetry. Okay, so a lot of stuff to do here. So let's just plug in a few points here. Let's start with the x and y intercept. It's always good to start with that. So to find the x-intercept, you plug in y equals 0. So that would be x equals 0 cubed over 4, which is 0 over 4, which is 0. So there's an intercept for the x-axis on 0, 0. Plug in y equals 0, or x equals 0, so that'd be 0 equals y cubed over 4. Multiply both sides by 4, 0 equals y cubed. Cube both sides, you get 0 also. So they have the same x and y intercept. They cross at 0, so it only crosses at 0, it looks like. So let's just plug in a few values here. Because it's solved for x, I'm going to plug in a few y values. So maybe like -2, -1. I don't need to plug in 0, I already know it, and 1 and 2. Let's see if that's enough points here to kind of get a sense of what's happening. So I'm going to plug in 1 first just because it's easy. So that would be x equals 1 cubed over 4, which is 1/4. So 1/4 comma 2 is right up about there roughly. Can you graph the x value first? So that would be 1/4 comma 4 there. Plug in 2, so that would be 2 cubed, which is 2 times 2 times 8, which is 8 over 4, which is 2. So the point 2, 2 is a point. Why did I put this? I think I put that in the wrong spot, so sorry. 1/4 comma 1, right? 1/4 comma 1 would be right about there. That looks better already. Okay. Let's plug in -1, so that'd be -1 to the third, which is -1 over 4, which is -1/4. So -1/4 comma -1, right about there-ish. And plug in this one. This would be -2 to the third is -8 over 4, which is -2. So -2, -2 is a point. I think we need to plug in a couple more. So sorry, x and y values. 3 and -3. Plug in 3 to the third is 27 divided by 4. 27 over 4 is about, let's see, 4 times 7 is 28. So 6 2/3, or so 6 2/3-ish, comma 3 would be right about here. You can probably see what's happening to the graph on the right. Kind of looks like half a parabola. Goes up and to the right forever. If you plug in -3, you get -27 over 4, which is like -6 2/3. So -6 2/3, -3. Okay, we have it. And that's a pretty nice graph. It almost looks like parabolas, but not quite. They're just really, they're increasing at a smaller and smaller rate. They keep going up to the right and down to the left for this graph. It is a symmetrical with the, you can almost look at it and see symmetry. Is it x-axis? No. Is it y-axis? No. Origin, it might be. So I'm definitely going to do the origin symmetry test, which is plug in both -x and -y. So -x equals -y to the third divided by 4. Well, -y to the third is always negative. So that's -x to the third, or y to the third, divided by 4 equals -x. Both terms change sign, so that is the same function. So it does have what's called origin symmetry, and it looks like it does. Right? I just had to prove it. So it looks like you spin it around like a pinwheel on there, and it spins on top of itself. Sketch a graph. This one shouldn't take too long. -1, 1 is the center, and the radius is 4 because r squared. Using the formula, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, Well, test the equation for symmetry. So we can plug in negative x first to test for y-axis symmetry. Negative x squared times y plus negative x to the fourth times y to the third equals 1. So that term is always going to be positive because it's a negative squared. This term also will always be positive because it's a negative squared. So I think we started with the first equation. We ended up with it. So y-axis symmetry does have, plugged in negative x, we get y-axis symmetry. Let's test the y term. So this would be x squared times negative y plus x to the fourth times negative y to the third equals 1. What's interesting is the last term is the same. The 1 is the same, but this becomes negative, right? So this has no x-axis symmetry. And since it doesn't has one of these or the others, I guess I could test for origin, but I'm pretty sure it's not going to work out. So you could do one more test, but there's going to be no origin symmetry. You really would need both of the others to have origin symmetry, I think. For neither of the others, and maybe only origin symmetry, but since it has y-axis symmetry, it should have both if it's going to have origin. So negative x squared times negative y. So that term's going to stay the same. Now it's going to change. It's going to be negative x squared y. So you really are done at that point. This does not have origin symmetry. Find an equation of the circle that satisfies this. So the center, so this would be x minus h, so x minus negative 2x plus 2 plus y minus 5 squared equals 3/2 squared, which is 9/4. Endpoints of the diameter, so let's find the midpoint first. So I know the y value of the midpoint is 5 there, because they're both 5. Add up the two x terms, x1 plus x2 is 2, and divided by 2 is 1. So that's the center. Looks like the distance between those two, since you can do it in your head, is just a distance of 3. So the radius is 3. I guess that's the radius. And so our equation is x minus 1 squared plus y minus 5 squared equals 3 squared, which is 9. Show the equation of the circle. So we got to complete the square, group the x's, x squared, well, there's only x there, plus y squared plus 4y plus blank equals, subtract 3 to get 3 to the other side, you get negative 3. So this one is already perfectly factored. If you wanted to write it this way, if that makes you feel better, x minus 0 squared plus y plus, let's see, I'm going to do half that middle number squared. That would be 4 to each side. So y plus 2 quantity squared equals 1. Identify the HKR. That would be 0, comma, negative 2 is the radius, or the center. The radius would be the square root of 1, which is 1. There's no perfect window here. Let's see what happens when you graph it. X squared minus 12x minus 45. Okay, I can't see it. I expect a parabola because it's x squared, but I really can't see the rest of this. So you could zoom out. Let's try that. So menu, window zoom, zoom out number 4. Click there. Ooh, I'm starting to see it. That's good. Wow, I had to zoom out a bunch. So I can finally see all the points. This is not a good window because the y values look fine, but the x values are just way too big there. It looks like I need maybe 10 or 20, but certainly not what that is. Hit escape if you want to double click those. Let's make that, I don't know, 25. See if that's better. 25. Hit tab, hit tab. Make that negative 25. That's okay. I could even make that maybe a little bigger, -15. But it's a pretty nice view. Anything in that range, as far as, so you just write the end values, whatever they are, 100-ish, -119, 25, and the minimum value is -15. Find equation of the slope. Oh, this is easy. Point slope form, y minus 2 equals -2 times x minus -3. You're done. Using point slope formula. So the equation for y, so you graph the two functions in your inspire, so you want to get the x term over to the other side, so I'm going to subtract it, so you get y minus 2 quantity squared equals, not too worried about the form, so I'm just going to subtract that, x plus 3 quantity squared. Take the square root of both sides, don't forget, plus or minus, y minus 2 equals plus or minus the square root of 9 minus x plus 3 squared. Last, add 2 to both sides, you get y equals 2 plus or minus. By the way, that doesn't simplify. Don't think that it does. You're trying to take the square of the whole side, not each individual term there. Find the equation of the line with x-intercept. Okay, so x-intercept at -2 and y-intercept at 0, 4. So like x-intercept's -2, y-intercept is 4. So like right there, right there. If you draw that line, you should be able to figure out the slope, right? You go up 4 units, that's positive. To the right 2 units, that's positive. So it should be 4/2 or a slope of 2. So I've got a slope and I've got a point. That's all I need, right? Y minus 0 equals m, which is 2, times x minus -2 or x plus 2. And you've got it. Or you could just say the slope is, you could have just gone straight to y-intercept form because we know the slope is x and we absolutely have to know the y-intercept is 4. So that would also be true as well. Parallel to the y-axis. Let's plot this point. So there's some line that's parallel to the y-axis, so that will look something like that. Well, it'd be just a touch higher. It goes through that point at 0, 5 there. It hits that point as well. So it's going to be a horizontal line, so y equals 5. That's what the y value is. Find the equation of the line, then graph it. So you might want to solve this one for y first. Find the slope and y-intercept, right? So I'm going to subtract 3x and -4y. I'm going to subtract 12 as well. -4y, so it's the y, equals -3x minus 12, because I subtracted both those things. Divide by -4, divide by -4. Y equals positive 3/4 x plus 3. If you want to graph that, up 3/4 or down 3/4 the other direction. Something roughly like that. Perpendicular to that line. So let's look at that first. So the slope is going to be, the perpendicular slope will be opposite reciprocal, so -3/2 passes through this point. It does say put your answer in slope-intercept form. So if you want to use the slope-intercept form, y equals mx plus b, let's plug in all our points. That's our x, that's our y. So 2 equals -3/2 times x, which is -4, plus b. Just solve for b. 2 equals 12/2 plus b, which is 6. Subtract 6, you get -4 equals b. So my equation is y equals -3/2 x minus 4. graph this. So you have a couple different options. Some students like to, get it all on the same side. 1 plus square root of x minus square root of 1 plus x squared. Then you graph the left-hand side there. So 1 plus square root of x minus square root of 1 plus x squared. Okay, and so you want to find out where this crosses the from 1 to 5. So I'm going to say from 1, for my x values, tab, to 5. So it looks like it only crosses once there. Just looking at it, it may cross another spot, but it looks like it does cross, right? If you use trace menu 5.1, should tell me, there it is, 2.31. So x equals 2.31 is my solution. You want to write in that form. Don't write the ordered pair. That's not really what we're looking for. We're looking for the x value of that ordered pair, the solution. Pairs inversely. So this will be y equals k divided by x. Oh, wait. Let's not use y's and x's. Let's say z equals k divided by t using these variables. So if t equals 15, okay, and z equals 3, solve, multiply by 15, you get k equals 45. So my equation, plugging that back in, would be z equals 45 divided by t. And then if they ask me a follow-up question, I'd be able to find it. And lastly, find k when x is 5. So t is jointly proportional. So k times x times y, and inversely proportional to r. That's the times there, divided by r. So it says that t equals 50. We don't know k yet. X is 5. Y is 6. And r is 3. By the way, that cancels. So you have 10, k up top, divide by 10, you get 5 equals k. Plug that back in, you get t equals 5 times x times y divided by r. And that's it. If you want to look at this, I think it's got most of the answers there. Just make sure I got mine right and then check them so you can double check that. 5xy divided by r, I think that's what I got.